Okay, question 11. A tank in the shape of a cuboid is being filled with water. So the base of the tank measured 20 meter by 10 meter and the height is 5 meter, as shown in figure 1. At time t second, t minutes. So always be careful with the units for modeling questions. Yeah. So this time the units is minutes. And then after water started flowing into the tank, the height of the water was h meters, and the volume of the water in the tank was v meter cube. So in the model of this situation, the side of the tank has negligible thickness. The rate of change of v is inversely proportional to the square root of h. So for this one, we can write this as so dv over dt. So it says the rate of change of v is inversely proportional. So that would be some constant over square root of h, just root h. And then because it's the water flowing into the tank, so it's positive, it's increasing. So it's just positive. Yeah. And then part A, show that dh over dt equal to lambda root h, where lambda is a constant. All right, so for this one, because we need to work out dh over dt, so then we don't have h and t equation. So that means we definitely need to use chain rule. So it has to be dh over something times by something over dt. And then we already know dv over dt, so we definitely need to use it. So that means dv over dt for this one, then the other one has to be dh over dv. And then to work out an equation v in terms of h. So v is the volume of the water, and then h is the height of the water. So to set up the equation is very simple. Volume has to be equal to 20 times by 10 times by h, which is equal to 200 h. So that's the volume of the water in terms of h. So then dv over dh is just equal to 200. So in this case, dh over dv is just a reciprocal. So it's 1 over 200. And then times by dv over dt, which is k over root h. And then since k is a constant, 1 over 200 is a constant. So times them, that's just another constant. So we can use lambda to represent it. So that's why dh over dt is equal to lambda over root h. That's part A. And then for part B, given that initially the height of the water in the tank was 1.44 meter. So from here, we know when t equal to 0, the height is equal to 1.44 meter. So, and then h is in terms of meters, so you can just use h as 1.44. And then exactly 8 minutes after water started flowing into the tank, the height of the water was 3.24 meter. So what's the units for t? So t is in minutes. So then we can just let t equal to 8 and then h equal to 3.24. So that would be our two conditions. So now to solve that, we just have to integrate it. So for part B, we know dh over dt equal to lambda over root h. So our times by root h for both sides, that'll be root h dh equal to lambda and then times by dt, so lambda dt. And we'll integrate it for both sides. And then root h is h to the power half, so plus 1 the power becomes 3 over 2, and divide the power 3 over 2 equal to lambda t plus c. And then h to the power 3 over 2, so they want h to the power 3 over 2 as a subject, so it times by 3 over 2. That'll be 3 over 2 lambda t plus 3 over 2c. And then again, 3 over 2 lambda is just some constant number. So because lambda is a constant number, 3 over 2 is a constant number. Constant times constant is just another constant. So we can use capital A to represent it. And then 3 over 2c, we can use capital B to represent it. So now we just have to find what A and B is. So we have the two conditions. So we have two unknowns. So then that's sufficient enough to find what A and B. And then it's up to then when t equal to 0, h equal to 1.44. So 1.44, the part 3 over 2 is equal to anything times 0 is 0, so b is equal to 1.44 the power 3 over 2. So b is just equal to, put that in the calculator, 1.44 the power 3 over 2 is 216 over 125. So then we have h to the power 3 over 2 equal to 80 plus 216 over 125. And then substitute in the second condition. So when t equal to 8, h equal to 3.24. So 3.24, the power 3 over 2 equal to t equal to 8. That would be 8a plus 216 over 125. So then a is equal to, so 3.24, the power 3 over 2, and then minus 216 over 125, and then divide by 8 at the end. So that would be 513 over 1000. So then our final answer for this one would be h to the power 3 over 2 is equal to a is 513 over 1000 times by t plus 216 over 152. That's all. And then part C. Hence, find the time taken from when water started flowing into the tank for the tank to be completely full. So if the tank completely full, so that means the height of the water should be the same as 5 meters. So then to work out the time taken, we just have to let h equal to 5 and solve it. So 5 the power 3 over 2 equal to 513 over 1000 t plus 216 over 125. So then I will just do 5 the power 3 over 2 minus 216 over 125 equal to 513 over 1000 t. So I just put that in the calculator and then divide this for both sides. So 5 the power 3 over 2 minus 216 over 125. That would be 9.4523. And then divide by 513 over 1000, which is t equal to 18.4256. So just round it into one decimal place. So 18.4. And then the units for time t is minutes. So that would be 18.4 minutes. That's all.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.